So this is the last lesson of this chapter. Right now we have a quiz scheduled for tomorrow, but we'll see how many students are here. What's that? No. Okay, so right now we have a quiz planned for tomorrow, and then next week we'll be doing some review for the exam, which will likely be on Wednesday, but again, we'll see what tomorrow brings, how many students are here, whether or not we have the quiz tomorrow. So yesterday we looked and saw how we could solve inequalities when they're given to us. We saw that solving inequalities is almost identical to solving equations. The only difference is when you're working with inequalities, if you have to divide or multiply both sides by a negative number, the inequality reverses. So that is the only difference. So today we'll solve some problems where we need to write the linear inequality from a given context and then solve it to solve the problem. It's always a good idea to just look at your answer, look at the scenario, make sure your answer makes sense. So the first question says, when a number is doubled and increased by 7, the result is greater than 25. Write an inequality for this situation, then solve it. So you're trying to find out what that number could be. A number that when it's doubled and decreased by 7, the result is greater than 25. So we'll start by choosing a variable, say the letter A, equal the number. That's what we're trying to find. What number or numbers exist so that when we double them and decrease by 7, the result is greater than 25. So once you have your variable set, then you have to write your inequality. And when the number is doubled, that means it's multiplied by 2. So you're going to take the A and double it, multiply by 2. Decrease it by 7 means subtract 7, and the result has to be greater than 25. So there's our inequality. Notice it doesn't say greater than or equal to, just greater than. So that's what the inequality would look like. That's what we need to solve. So we'll start by adding 7 to both sides to get the 2a by itself. Minus 7 plus 7 cancel. You'll have 2a by itself on the left. And that has to be greater than 25 plus 7 is 32. And then we would divide both sides by a positive 2. So therefore the inequality will not reverse. And we'll get a is greater than 16. So any number greater than 16 should work. If you double it and decrease by 7, it should be a result greater than 25. And so we will check that. Let's use, let me write that better. Let's let a equal 17. Hi. Okay, so if we let a equal 17, if we double it, that'll be 34. And then we decrease by 7. "34 take away 7 is 27. And that is greater than 25, so that checks. We chose a number greater than 16, so we chose 17. And we doubled it, decreased by 7, and the result is greater than 25. What if we chose a number less than 16? Because again, we said our answer was that a has to be greater than 16. So what if we check using a number less than 16? So let's let a equal 15. Well, if we double it That'll be 30. And then decreased by 7. That'll be 23. And that's not greater than 25. So this shows that our inequality, our solution is correct. A number greater than 16 worked, but a number less than 16 didn't. Okay? Example 2 says Mindy is looking at a new cell phone plan that charges a flat rate of $40 per month plus 4 cents per text message. She does not want to spend more than $60 per month. So she could spend 60, she could spend less than 60, but she doesn't want to spend more than 60. Write an inequality for this situation and then solve it. So in this situation, there's always a flat rate of $40. That's not going to change. What does change is how many text messages she sends. And she is charged 4 cents per text message. So that's what we're going to let our variable represent. Let's say we let n equal the number of text messages. N equal the number of text messages. So her total bill is $40 plus 0.04 cents per text message, which is n, and that number has to be less than or equal to 60 because she doesn't want to spend more than 60. She could spend 60 exactly, that'd be fine. She could spend less than 60. So the amount that she spends has to be less than or equal to 60. So this is the inequality that we're now going to solve. So we could subtract the 40 from both sides. And so on the left, the 40s will cancel, and you'll have 0.04n less than or equal to 20. Because on the right side, 60 take away 40 gives us 20. And then divide both sides by 0.04. Again, you're dividing by a positive 0.04, so therefore the inequality does not change. And we have n less than or equal to 20 divided by 0.04. Oops. 500. So the number of text messages that she sends has to be less than or equal to 500. So it can be 500, it can be less than 500, it just can't be greater than 500. So again, if we do a check here, so let's let n equal 500 because that's a possibility. So her total charge would be 40 plus 0.04 times 500. It's 4 cents per text message plus the $40 flat rate. So you can put this in your calculator all at once in one step. 40 plus 0.04 times 500, which is exactly $60, and that's okay because she doesn't want to spend more than 60. What happens if we used a number greater than 500? Let's let n equal, let's say 501, a number greater than 500. So her bill that month would be $40 plus 0.04 times 501. So all that we're changing is we're multiplying by 501 instead of 500. And that gives us $60.04, which is more than she wants to spend. So again, this just shows that our solution that we came up with, that n must be less than or equal to 500, is correct. It does match what we want to happen. Okay, example 3 says that when Frank's age is divided by 4 and then decreased by 10, the result is more than 30. So what we're trying to find here is what Frank's age might be. So maybe we'll let F equal Frank's age. And when you take his age and divide it by 4, and then increase by 10, means it gets larger by 10, so we're adding 10, that result has to be more than 30 or greater than 30. So there's the inequality that we now need to solve. So I would subtract the 10 from both sides first. So on the left, 10 minus 10 cancels, and we have f over 4 is greater than 20. And now to get the f by itself, hooked onto the f is a 4 by division. The opposite of dividing by 4 is multiplying by 4. So we'll multiply both sides by 4. On the left, 4 divided by 4 cancels, and you just have f greater than 20 times 4 is 80. So Frank's age must be greater than 80. So if we're going to check this, let's let f equal 82. Just because I have to divide it by 4, so I'm choosing an even number. So divide by 4. That's 82 divided by 4, which is 20.5. And then increase by 10. That'll be 20.5 plus 10, which is 30.5. That is more than 30, so that checks. If we use a number less than 80, so here's another check. Let's let f equal 78, a number less than 80. So if we divide by 4, that's 78 divided by 4. Gives us 19.5. And then increase that by 10. $19.5 plus 10 is 29.5. Well, that's not greater than 30, which it's supposed to be. Okay, Shyla? So this just shows us that our solution is correct. When we chose a number greater than 80, we got a result greater than 30. If we chose a number less than 80, we didn't get a result greater than 30. So again, this just shows us that our statement, our solution is correct. It can be any number greater than 80 and it'll work. Example 4 says the perimeter of the figure below must be less than 48. So you have to remember that the perimeter is the distance around. You add up all the sides. So x plus 9, if I start with that and work my way around clockwise, the next side is 2, the next side is 9, the next side is x minus 5, the very bottom is x, and that left side is x minus 3. And that has to be less than 48. So we can simplify here by collecting all the x's. X plus the second x is 2x, plus another one is 3x, plus another one is 4x. If I add all the numbers together, 9 and 2 is 11, plus 9 is 20, take away 5 is 15, take away 3 is 12, positive 12. So there's the inequality in simplest form. And to solve this inequality, again, because we're told that the perimeter has to be less than 48, so to solve this, I'll subtract the 12 from both sides. So on the left, 12 take away 12 cancels. We're left with 4x is less than 48 take away 12 is 36. And then we're divide both sides by positive 4, so the inequality does not change because we're not dividing by a negative value. On the right, 36 divided by 4 is 9, and so there's our answer. X has to be any number less than 9. Are you here for Courtney? You here for Courtney?
Yes.
Okay. Thank you. So any number less than 9 should work. So if we check this on our diagram here, choosing a number, let's say 8. And it's always best to use the original expression, the original diagram. So this is our check with x equaling 8. So 8 plus 9 is 17. 8 take away 5 is 3. X is 8, and 8 take away 3 is 5. If we add up all these sides, 17 plus 2 is 19, plus 9 is 28, plus 3 is 31, plus 8 is 39, plus 5 is 44. So P will equal 44, which is less than 48. So it checks. And if we now check with a number greater than 9, because we said our answer has to be x is less than 9, if we check with x equaling 10, so now 10 plus 9 is 19. 10 take away 5 is 5. X is 10. 10 take away 3 is 7. If we check with these numbers, 19 and 2 is 21. Plus 9 is 30. Plus 5 is 35. Plus 10 is 45. Plus 7 is 42. No, that's not right. Let me try that again. 19 and 2 is 21. Plus 5 is 26. Well, I missed the 9. So 19 and 2 is 21. Plus 9 is 30. This will be 35, 45, 52. That's better. That should be 52. Which is not less than 48. It's greater than 48. So again, our inequality, our solution is correct. We've shown that any number less than 9 would work. The last example says, for what integer values of m will the perimeter of the square be less than the perimeter of the rectangle? So the perimeter, again, is the distance all the way around. The perimeter of the square, you have 4 equal sides measuring m plus 10. So this is an expression for the perimeter of the square. 4 sides that measure m plus 10. And that must be less than the perimeter of the rectangle. So the rectangle will have 2 sides that measure m plus 1 and 2 sides that measure 2m. Now you could add m plus 1 and 2m, another m plus 1 and another 2m, but that's the same thing as multiplying each side by 2. So we need to simplify this equation before we can solve it by multiplying out the brackets. So 4m plus 40 has to be less than 2m plus 2 plus 4m. Two m and 4m is 6m plus 2. And now we'll solve this. If I subtract the 4m from both sides, 4m take away 4m cancels. On the left, you have positive 40 less than 6m take away 4m is 2m plus 2. We subtract the 2 from both sides. And 40 take away 2 is 38. On the right side, the 2's cancel, and you're left with just 2m. And now you would divide both sides by positive 2. So because you're dividing by a positive, the inequality is not reversed. So on the left side, 38 divided by 2 is 19, and that has to be less than m, or m is greater than 19. M must be some number greater than 19. Always read from the variable. So let's check using m equals 20, because m has to be a number greater than 19. So when m is 20, 20 plus 10 is 30. All 4 sides will be 30, which is 120 units. And that has to be less than the perimeter of the rectangle when m is 20. So 2 times 20 is 40. That'll be 40. M, which is 20 plus 1 is 21. 21. So 40 and 21 is 61. Plus another 61 is 122. And that works. The perimeter of the square has to be less than the perimeter of the rectangle. And so that works. So we said that m has to be greater than 19 if we chose something less than 19. So let's check using 18. If m is 18, 18 plus 10 is 28. So all 4 sides would be 28. 28 and 28 is 56. And there's 2 of them, which is 112. When m is 18 for the rectangle, 2 times 18 is 36. 18 plus 1 is 19. So 2 times 36 is 72. 2 times 19 is 38. That's 110. The perimeter of the square is greater than the perimeter of the rectangle, and that's not what we need. So again, we've just shown that m is greater than 19 does work. Any number greater than 19 will work. Okay? So that's it for this chapter. Again, the plan right now